Okay, so I'm doing a video over 1993 because y'all said y'all need it. So we have these equations right here, and then we have the question. The amount of oxygen O2 dissolved in water can be determined by titration first. And so it tells you the steps of the titration. And this is the equations being represented below the net ionic equations. According to the equation above, how many moles of S2O3 are required for analyzing 1 mole of O2 dissolved in water? So if we do stoic, so we start with our given. So I will block this off for a second. So if we start with our given, which would be 1 mole of O2, we want to convert. So we're just looking at these stoichiometry coefficients. And so we're going to work backwards essentially. And so I'm going to find my oxygen, which is that first equation. And then I need to find something that links it to the second equation and something that links it to the third equation. So what we're going to end up doing is going O2, and then something that's common in both problems is that MnO2. So then I'm going to go to MnO2. Then I'm going to go from MnO2 to, and then the third equation, which would be the things that they have in common would be the second and third equation would be that I minus, so your iodine, so you're going to go I minus. Then I'm going to take my I minus, and then I'm able to go to the S2O3 that it asks for. Yeah, that's what it asks for, 2, okay? So that's how those connect. So hopefully you can see as you follow along. So I'm going to go with the 1 mole of oxygen. I'll look at its stoichiometry coefficient, and it's just a 1, so that's a 1 mole O2. And then I'm going to look for the moles of MnO2. And that first equation, if you look, it has a 2 in front of it, so it's going to be 2 moles of MnO2. So then moles cancel. So now I'm in moles of MnO2. So next I want to go to that I. So then if I look on the next problem, for every 1 mole of MnO2, I have the I2. And so this one, you're going to use a 1-to-2 ratio with. 1 mole MnO2 is equal to 2 moles of the I minus. So then this cancels and this cancels. And then we have the I2 to the S2O3, which would just be a 2-to-2 ratio. And so we have a 2-to-2, this would be 2 moles I. And then this one is moles of S2O3, 2 minus. And so then these cancel out, and so you're left with just 4 moles. For every 1, you're going to get 4. And if I go look at the answer key, it says the correct answer is 4 moles. And so hopefully that makes sense on how to do part A. Part B, are you following along? 1993. Part B says, so part B says a student found that 50 milliliter sample of water required 4.86 milliliters of a molar solution to reach the equivalence point. Calculate the number of moles of O2 dissolved in the sample. And so we haven't really talked about titrations yet, but whenever we go through titrations, I have a titration ed puzzle for y'all to do on Friday. And whenever you go through these titrations, you'll learn what they're talking about. And so it's like a neutralization most of the time. It's a color change. You're looking for a color change, which is what that equivalence point is going to be. And so all of these different volumes are important. And so we have to organize and write them down. Let's see what C says. How would the result in B be affected if some I2 were lost before the S2O3 was added? And then what volume of O2 measured at 25 degrees Celsius and what atmospheric pressure would have to be dissolved in 1 liter? So B is going to take me more than this. I only have 10 minutes per YouTube video to do. But we can go ahead and try to do, so for a titration, first of all, and you'll see this in your notes, you have some substance in a flask, and then you know the volume, and you know this, this substance, and then you are going to, you know what it is, and you know its volume, but you don't know its concentration. And so you're gonna drip something that you know. You add an indicator. So you have your substance, this could be like hydrochloric acid, and you have an indicator in there too. An indicator is gonna change colors whenever this changes substances. So in this case, I have an acid in there. And so if I drip enough in and it becomes a base, my indicator would tell me by a change of color. Either it'll go from color to colorless, from one color to another, from colorless to color, but some sort of change is gonna happen. So that's what a titration is. And so that's essentially what's happening here, is how they have it set up. So we have to go back up to the top and read the titration part. First, MnSO4 and NaOH are added to a sample of water to convert all of the dissolved O2 to MnO2, as shown in equation 1 above. Then they use sulfuric acid and potassium iodide are added, and the reaction represented by equation 2 proceeds. Finally, I2 that is formed is titrated with standard sodium thiosulfate. So that's our titration. So they're doing other mixtures first, and then we have our titration last. And so if we go to the next part, a student found that a 50 milliliter sample of water required 4.8 milliliters of molar concentration of thiosulfate to reach the equivalence point. And so we know we have our water. We'll see how far along I can go with this. Water, I have 50 milliliters. In chemistry, we don't like milliliters. We want it to always be in liters, so I'm going to go ahead and convert that over 050 liters. And then we have for the thiosulfate, it required 4.86 milliliters of a 0.002. So I know I have for the sodium thiosulfate, which the sodium part really doesn't matter because this is actually going to break apart. It is soluble. And so really we're talking about the concentration of these S2O3 2- ions. That's essentially what this is. But it's telling me that I have this, is it 2 zeros or 1? Just 1. Concentration, and I know that that's just the bell for lunch. I know that my volume is that, which I'll turn this a little bit so you can see that. And so I can then solve for the moles of that. I know how much moles of sodium thiosulfate I had to add. Hopefully everybody can see how we do that. And it wants to know the number of moles of O2 dissolved in the sample. So you're working backwards. So you're going to solve for your moles of sodium thiosulfate, which you just multiply these because a big M, this is saying that it's moles per liter. And so if you multiply it by that, you're going to get your moles. And then you're plugging it in backwards. And actually in part A, you already did all that work. You know that 1 O2 mole is equal to 4 sodium thiosulfates. And so if you know that you have this much sodium thiosulfate, you're just dividing it by 4. So hopefully that one makes sense. And I'm at 10 minutes, so we're going to stop.